because it's learning target 3.7. Nutrients necessary for bone growth and their function. First one, calcium and phosphate and other minerals, including potassium, sodium, magnesium, carbonate, and zinc, fluoride, iron, all the minerals that we think about. Lots of them work with bones. These are the materials we need to mineralize collagen and make bone. What does that mean? That means that we start with collagen, which is going to be just these blue fibers here, right? This is like our skin. The collagen is just strong fiber, but it doesn't have that structure that's that we need for bones, because collagen is still flexible and we can still bend it. So what we're going to do is we're going to take our calcium, right, and our phosphate, and we're going to stick that onto bones. The osteoblasts are going to help this happen. And once this starts happening, our bones are going to become hard and strong. So we're going to get all these minerals stuck onto bones. And when that happens, our bones are going to become this hard structure that's unbendable. We're going to get all of these minerals through our diet and the foods we eat. We need to get these from outside of our body. We can't make them. So the foods that are high in calcium and phosphate and potassium and all these other things are what we're going to get this nutrients from. What would happen if we didn't get the minerals? Look at this picture. You can take out all of these circles, right? And take out all the minerals, and what's left over is collagen. So our bones would be made of just collagen, which means it'd be like the dermis of our skin. So our bones are going to be soft and squishy. Still tough, but it's not going to be what we need for bones. The second thing we need is calcitriol, which was made from vitamin D. So we need both. We need vitamin D to get calcitriol. Vitamin D we make from taking ultraviolet light right here. Ultraviolet light, radiation from the sun, hits our skin and turns cholesterol into vitamin D. We take cholesterol, radiate it, energize it, and it turns into vitamin D. We send vitamin D to the liver, and then the kidneys, and it eventually becomes calcitriol. Calcitriol helps with bone deposition, meaning that we sticking bone deposition. Bone deposition is a process where we take all of these circles, right? We take the circles and we stick them on. That is bone deposition, sticking the calcium and phosphate on. It's also going to help with reduced excretion of calcium and phosphate, which means that when it's running through our body, we're not gonna urinate it out. It's gonna stay inside of us, and it's gonna help us absorb it from the foods we eat. So everything to do with calcium and phosphate, the minerals, is calcitriol. Calcitriol and vitamin D deal with the calcium and phosphate. They deal with putting it on bones, keeping it in our body, and getting more from our food. Getting it from our food, keeping it in our body, and then sticking it onto bones. What would happen if we didn't get these two, calcitriol, vitamin D, or we didn't even get any sun? Our calcium and phosphate wouldn't get put on a collagen. We would eat all our calcium and phosphate in our diet, but we wouldn't absorb any of it. So we drink milk, and all the calcium and phosphate just goes out the other end. So our bones, again, are going to be made of just collagen. If we didn't get, so we need solar radiation to get vitamin D to get calcitriol. If we don't get any one of those, we're going to have, our calcium and phosphate is not going to get put onto bones. Why is it a problem for our melanocytes to make too much melanin and absorb the radiation from the sun? I'm saying that the radiation from the sun, ultraviolet light, hits our skin, and that makes vitamin D. If we have melanin, we can block that vitamin D So we need, if we have melanin, it'll be in the top layer of the skin. And the ultraviolet light is going to get stopped. So if we have too much blocking happening, we're not going to make vitamin D. This won't really be a problem unless you don't go in the sun very often, or you live in an area where there's not very much sun. Vitamin C helps with bones because it helps make the collagen, and it helps other cells become osteoblasts. So, right here, this osteoprogenitor cell is going to get turned into an osteoblast because vitamin C affects it. It turns the it sends a signal to the osteoprogenitor cell, and it says, vitamin C tells it vitamin C tells it to change into an osteoprogenitor. Vitamin C tells the osteoprogenitor cell to turn into an osteoblast, and vitamin C also is going to help make the collagen. So we can, that collagen right there, that blue stuff that you see, is going to be made by vitamin C. Vitamin C is going to tell osteoprogenitor cells, other cells, to become osteoblasts, the cells that make our bone, and it's going to help us make the collagen we use to make bone. What would happen if we didn't get vitamin C? We wouldn't make collagen. So that all the fibers that we need to put the minerals on are not going to be there. We would have, if we didn't have vitamin C, our bones would be just minerals left over. All that collagen would disappear, and we just have minerals, which, as you can see, are these just ions. These circles aren't gonna be really good for our bones. It's not gonna make bones at all. We need vitamin C so we can have that collagen and put the calcium phosphate onto it. And we need vitamin C so we can have osteoblasts, so our bones will grow. Because if we don't have vitamin C here, we're not going to tell it to change. So if we don't have vitamin C, we're not going to have this signal happening right there. So our osteoprogenitor cells, first follow the chain of events, right? If we stop that happening, that signal, we're just going to stop our osteoprogenitor cells becoming pre-osteoblasts, which is going to stop them becoming mature osteoblasts, which is going to stop us making bone. So if we stop that signal that from vitamin C, we're going to stop our pre-osteoblasts from working, which if we stop one part of the chain, we're going to stop everything else in it. So we'll end up with not enough bone. Thyroxine and growth hormone. Thyroxine helps cells use more energy. So thyroxine is going to be the lightning bolt for the osteoblasts, right? Thyroxine. Thyroxine makes them work faster. So right here in this osteoblast, thyroxine is going to electrocute it with, it's like an electrocution or energizing. It makes the osteoblast work faster. So we are going to get tons and tons and tons of we're going to get more and more bone because it just works faster. It deposits more, right? We're going to get more bone because thyroxine is happening. The growth hormone tells all the cells in our body to grow. It's also going to tell our bone cells to grow too. So it'll signal the cells not only to work faster, but also to make more of themselves. The end.